Question 35 is looking at someone investing money, paying out $3,000 per annum. Now, this is an annuities in arrears scenario because the person has invested the money and someone's paying him out gradually. Now, because it's annual, 1.05 t to the n, they're paying out $3,000 per year, and the initial figure is $50,000. Needless to say, this is where your calculator comes into its own. Now, when you enter that, make sure that you've got the figures there. Hit the table. But what you might have to do also is to make sure you've got quite a few years. I chose 50 on my scaling, so it enabled me to get a pretty good readout of the figures. Scrolling down and recording the first 5 years, if you like, or the start and 4 consecutives, quite easy to do. You'll notice that the decimal points are clipped until you pull them down. And you can see I've had to tweak and adjust mine a little bit. And when it comes to the graph, you can see here how things have decreased there. I might change my scaling just a wee bit. So I might make my maximum 60,000. The minimum 0, so I can get everything on the scale. The trial and error here won't hurt. That looks pretty right. So you can see the progression of the graph there. Now, if I go analysis trace, that would help me to replicate it for a period of time. Now, it looks like when I scroll down that the amount of money is dropping obviously over time. So after 25 years, we've got 26,136 left. If I continue that down, as I said, I've done mine to 50. I'm down the negatives by the time I get beyond 36. So it looks like it's going to last just over 36 years. You can do the graph. After 20 years, just scrolling back up, you can see that we've got 33,000. Now, just let you see all that. Now, if the scholarship was adjusted so it could last forever, we want to find the difference whereby the next term is the same as the previous. So this means when t to the n plus 1 is equal to Tn, that means the constant 50,000. So I need to find D. We're assuming the interest rate is constant. So I need to solve or 50,000 is equal to 1.0 times 50,000. Take D. And when you work that out, that'll be 2,500. So in other words, the annuity, or I should say the perpetuity, constant amount that can be pulled without affecting the balance, can be $2,500. That's an equilibrium scenario. Now, just showing you very, very quickly on the calculator. I'll go back to this. And I'm only taking 2,500, and that stays the constant 50,000. So on the data tab, you can see that constant balance of 50,000 remains. Good little question to look at.